The Department of Artificial Intelligence, commonly referred to as AI, at Makerere University's College of Computing, Artificial Intelligence and Machine Learning focuses on three areas: agriculture, health, and natural language processing.
And I'll go through each of the areas and then describe the project that we are doing. And I know that there are people who have been working on this for long, especially we have a PhD student, we have several master students as well. And I think when we have the deeper interactions, then we shall get to go deeper into the kind of work that we're doing. So maybe I'll start with agriculture. So I'll go agriculture, health, natural language processing, and I think transport is the last one. So
in agriculture, Makerere University's AI has focused on a cassava project. The project has been diagnosing post-harvest physiological deterioration, or PPD, of cassava using images.
Later we have built machine learning models here that are able to do the automatic diagnosis. So if I take a picture of a leaf that has a disease, it's able to say that this disease has been identified, maybe CBSD. If it's healthy, it will say this is healthy. And so once we get the data, we aggregate the data together and we plot it quickly on a map. So something that could have taken, for example, 6 months for turnaround, within maybe a day or two after cleaning the data, analyzing the data, we're able to visualize that data on a map and pass on that information already to the agriculture experts to say, okay, this is the state, what we've observed now in January, this is the state of the garden, maybe from the 4 sub-regions that we are working with.
The images taken of cassava leaves help to detect the disease at an early stage. No other technology would be able to detect the disease at this stage. The project also incentivizes farmers by providing them with low-cost smartphones to take photos of the plants and share with the project managers.
We have the mobile applications for disease diagnosis with the AI model inside, and we've embedded and built this to fit on a mobile phone. So with the projects that we've been able to run, we've got some funding to buy some low-cost, low-end mobile phones where these mobile applications have been installed and given to the farmers, and the farmers are also able to do the actual diagnosis for themselves in the field. So you go take a picture of your cassava and automatically you're able to be told that your cassava is suffering from cassava brown streak disease.
Makerere University's Department of Artificial Intelligence in Health has also developed a malaria diagnostic kit that uses a microscope and a smartphone. The kit is solving the problem of lack of lab technicians. It uses 3D printable adapter to capture images of the microscope through a smartphone. The project then works with lab technicians who detect pathogens in the images, and the malaria parasites are detected with more accuracy.
With the use of technology, we have a 3D printer. I think we need to get somewhere when we get money. So we have a 3D printer that has been able to print devices that you can connect a mobile phone to the microscope, such that at the end, you don't have the person looking through the eye, but you have the mobile phone taking an image of the microscope, and we have built machine learning models that are able to automatically do the count for you. So the models are on the mobile phone. What the person does is you just have a connector between the phone and the microscope. So you just take the phone and plug it on the connector. I think there's a picture that shows that. And when you take the image of the microscope, the diagnosis is done for you automatically with the machine learning models that we've done.
So as we're using this camera, it can be of any phone, then the camera is set direct to the eye lens, and it picks the image from the objective, then direct to the camera. So the camera gets the image. So from the image, it is displayed on the camera of the phone, on the screen of the phone. Then we can adjust the resolution, and we are using ×10 to create a wider image.
We want to solve the problem of the lack of enough lab technicians in our health facilities. Since we have microscopy as the gold standard diagnosis of malaria, we thought we could be able to improve the way the microscopy carries out the diagnosis. So here what we've done is that we've developed a 3D printable adapter which we attach on the eyepiece of the microscope, and then through this we can be able to capture images of the microscopy through the smartphone.
You can just tell, you can read the slide just on the phone's screen. You can see the white cells, you can see the malaria parasites. Once you've seen a field is marked. We mark the range and the line at the spot from which that image was taken. Then you can click on the camera to make that image. So the image is already saved.
We are working in collaboration with the lab technicians in Mulago, Chirudu Hospital, who are able to annotate for us the pathogens under these images. So once they have annotated for us and given us the characterization of the pathogens in the blood samples, we are now able to train these many huge number of images using artificial intelligence algorithms. This has helped us to be able to detect malaria parasites in blood samples with a lot of accuracy, and at the same time having a big throughput at the end of the day. This is able to augment the work of the lab technicians, where they will be straining their eyes to look out for these pathogens under the microscopes, they are able to sit at the comfort of their chairs through their smartphones to be able to capture these images, and then the algorithm is able to direct them to good examples of the pathogens so that they can make very confident and well-informed decisions about what is under the microscope.
The malaria diagnostic kit is intended to benefit remote areas and is being tailored to achieve higher efficacy levels in different categories of patients such as pregnant mothers and children. The kit will boost field malaria testing. Makerere University's Department of Artificial Intelligence is also working on natural languages processing. The project has developed a website where volunteers are doing text-to-audio translations of Ugandan native languages to English and vice versa. Visit commonvoice.mozilla.org/LG to lend your voice now.